Hello and welcome to yet another South Korean College Scholastic Ability Test video. Today's problem is as follows. Omega is one of the non-real roots of the equation x cubed equals 1, and for natural numbers n, function f of n is defined as f of n equals omega to the power of 2n divided by omega to the power of n plus 1. Find the value of f1 plus f2 plus f3 plus ... plus f20. Alright, let's see what we can use. Since omega is a root of x cubed equals 1, we have omega cubed equals 1. So we have omega cubed minus 1 equals 0. And if we factor the left-hand side, we have omega minus 1 times omega squared plus omega plus 1 equals 0. Since omega is not a real number, omega minus 1 cannot be 0. This means that this part is 0, that is, omega squared plus omega plus 1 equals 0. By the way, solving this quadratic equation gives omega equals negative 1 plus minus square root of 3i over 2. So omega is one of these two complex numbers, but the thing is, we don't really need this value to solve this problem. So you are not going to see this value ever again in this video. Let's get to function f of n. We want to find the value of this expression. Of course, you can calculate individual values of f1, f2, f3, and so on if you want, but let us think about more elegant approach. Remember that we have omega cubed equals 1. This means that we can find a pattern for general integer exponents by dividing the cases into 3k, 3k plus 1, and 3k plus 2 for integer k. Omega to the power of 3k equals omega cubed raised to the power of k, and since omega cubed equals 1, we have 1. Then omega to the power of 3k plus 1 equals omega to the power of 3k, which is 1, times omega, so it is equal to just omega. Likewise, omega to the power of 3k plus 2 equals omega to the power of 3k, which is 1, times omega squared, so it is equal to omega squared. Therefore, as for the values of function f of n, we can also find the values for general cases, f of 3k plus 1, and f of 3k plus 2. f of 3k equals omega to the power of 6k divided by omega to the power of 3k plus 1, and omega to the power of 3k equals 1, hence omega to the power of 6k also equals 1, so we just have 1 divided by 1 plus 1, hence 1 half. Omega to the power of 3k plus 1 equals omega to the power of 6k plus 2 divided by omega to the power of 3k plus 1 plus 1. Here, notice that omega to the power of 6k plus 2 is equal to omega to the power of 6k times omega squared, and since omega to the power of 6k equals 1, all that's left is just omega squared. And I have already explained that omega to the power of 3k plus 1 equals omega, so the denominator is omega plus 1. Here, remember that we also obtained the relation omega squared plus omega plus 1 equals 0. This means that the denominator, omega plus 1, is equal to minus omega squared. Therefore, we obtain negative 1. As for f of 3k plus 2, this is omega to the power of 6k plus 4 divided by omega to the power of 3k plus 2 plus 1. Here, the numerator is a product of omega to the power of 6k plus 3 times omega. And since 6k plus 3 is a multiple of 3, this part right here is just 1. And the denominator is omega to the power of 3k plus 2 equals omega squared, hence omega squared plus 1. And using this relation again, the denominator, omega squared plus 1, is equal to minus omega, so we obtain negative 1. Therefore, as for this summation, we can group them by 3 because the values of the function repeat by periodicity of 3. So we can group the terms until f of 16 plus f of 17 plus f of 18. And in the end, we have f of 19 plus f of 20. Here, as for the first group, f of 1 equals negative 1, f of 2 equals negative 1, and f of 3 equals 1/2, which gives negative 3 over 2. That is, each of this group also have a value of negative 3 over 2. Therefore, we have negative 3 over 2 repeated 6 times, and then this part, and f of 19 is negative 1 and f of 20 is also negative 1. So we obtain the final answer, negative 11. And that's all for today's video. Thank you for watching. Please don't forget to hit that like button if you enjoyed this video, and I will see you in another video.